Hi guys, in this video we're going to do two basic trigonometric differentiation questions, just two examples. In these two examples we're going to make use of the chain rule to differentiate them. We've got one a sine of a particular function and one a cosine of a particular function. So the first thing we have to do is we have to identify, especially with the chain rule, what the inside and the outside functions are. So here what we've got is we're going to separate this into the function y in terms of another function. So I'm going to write this as y in terms of u. So I'm going to go right, this is sine of u. And then I'm going to break this up, and then I'm going to say, and I've also got u is equal to x squared minus 3. So basically what the chain rule says is if we've got a function inside another function, the total derivative in the end will be like dy dx will be equal to dy du times du dx. So it's quite simple. So what we do first is, I'll write out the chain rule just quickly. So we're going to say dy dx, the total derivative, is equal to dy in terms of like a new inside function, du, times du in terms of our original explanatory variable, x. So what we can do then is we can literally just fill in our bits and pieces. So we have the derivative of y in terms of u is the derivative of sine is equal to cos. So we have cosine of u. And we have to multiply by that by the derivative of u in terms of x. Well, that's just 2x. So our answer then, after substituting u back into our equation, we know u is this, so we're going to stick that in there. And all we do is just say that the derivative, I'm going to put the 2x out the front, is 2x cosine of u, which is just x squared minus 3. And there is our first derivative done. We've made use of the chain rule. And we're going to change colour and make use of the chain rule again. The way we're going to use the chain rule here is we're going to appreciate that we can rewrite this function like this. We can go, this is equal to cos of x to the power of 5. So, once we've done that, it's fairly easy to see what the inside and the outside function is. On the outside, we have a fifth power function, and on the inside, we have cosine of x. So first of all, if I'm going to write my y in terms of u, I'm going to go y is equal to u to the power of 5, and I'll put a comma, my u is equal to cosine of x. So writing out my chain rule again, just going about it the very long way, that's supposed to be a d. Dy dx is equal to dy du times du dx. So y in terms of u is just going to be 5 u to the power of 4. So that's just very basic, that basic differentiation algorithm where you take the power down and you reduce the power by 1. Multiplied by, that looks like a x. Let's just put a dot. Multiplied by the derivative of u in terms of x. So the derivative of cosine is negative sine. So I'll put it in brackets. There we are. So what we do now is we just, again, substitute in our u. And I'm going to move the negative out to the front. So I'm going to say my dy dx is equal to negative 5. Put the u in. Cosine to the power of 4 x. Then I can just write my sine of x at the back times sine of x. So we've made use of the chain rule in both cases. Using when you're doing, trigonometric differentiation, you will make use of the chain rule more often than not, because more often than not, there is going to be the sine, the cosine, the tangent of a particular function in here. It's not going to just be x. If we're talking high school sort of calculus here anyway. So I hope these two examples helped, and I'll see you next time.